Welcome again to my live coding stream, where we are finishing up our GIF decoder today. Just hold on 1 second. Yeah, okay. Just checking I had the microphone selected. How's everyone doing? So where did we get to? Where did we get to last week? So we got somewhere that I thought was pretty exciting. We have our GIF, and it decodes, and it plays, and that's awesome. And this isn't complete, obviously. We're not completely done yet. It doesn't play on a loop. There's some graphical weirdness there. All of that white space where it looks weird is it's where the transparent color is being used, and we weren't quite sure what to put in as the background because it doesn't seem like they should all be the exact same color. So that's weird. So that's a bug to fix. And also we discovered that this wasn't the best performance that it could be. So if we do a timeline here, stop there. We are really pegging the CPU on every frame and not getting great frame rates out of it. But I have a plan. I have a plan for how we can fix that sort of thing. So, what to begin with? Well, just before the stream, about 2 minutes before it came on, I noticed a bug. I noticed a bug in the code. So let me fix that, because that's pretty simple to do. Here, when we're deciding whether to draw the pixel, we look to see if the transparent color flag is true, and whether the pixel is not the transparent color whether the current pixel is not the transparent one. So if the pixel is not the transparent pixel color, fine, we can draw it. But this flag is wrong. This says, so in the event that there wasn't a transparent color flag, we would draw no pixels. So any frame that doesn't have transparency would not get drawn at all. So this should be if there isn't a transparent color flag, or the pixel is not the transparent color. Sadly, I don't think that makes any difference to our case. Oops. Stop. I'm not trying to do it. Yeah, no difference, because clearly we are drawing some pixels, and the transparent colors are not getting drawn. So that's not our problem. Not our problem in this case. So, because I'm not quite sure what to do about the background color, and you can actually see, I don't know if it's easy to see, but there are some parts here that are still white at the end. Some parts that no frame draws to. No frame draws to those pixels. Yeah, so not really sure what to do about that. Now we did actually, when I was drawing in the background color for those, that seemed very wrong. Didn't look right at all. Maybe I had the background color wrong. So background color index. Let's go in here. Background color index. Oh, is 0 because we haven't read it yet. We parsed the header and the screen descriptor. Now background color index is still 0. Background color index is 0. Transparent color index is 0. Maybe they should be different colors. Maybe I'm reading one of these incorrectly or not setting it. Perhaps I'm not setting it. That's a reasonable choice. So let's read our header. Oh, the header is just the bit that says GIF 89A. Don't care. Logical screen descriptor. We're going to width and a height. Global color table flag. Yes, we have a global color table. Color resolution. Color table size. Background color index. Read a byte. And that's 0. Okay. Where do we get the transparent color? Now that is later on. That's per frame. So you can see we've drawn the background color on, and it's this green, and that just seems unlikely. I feel like the background color shouldn't really be in play here. So on the chat we have a question. What's the difference between the background and the transparent color? So the background color is the initial color for the canvas. So it only gets drawn once, right at the very beginning. And then anywhere that you have, so it only gets drawn initially, and you never draw the background color on again. For the transparent color, each frame could have its own transparent color, and that just means that you don't draw it this frame. So it's not that you draw the background color in instead of the transparent color, it's whatever the color of that pixel on the previous frame was. That's what the transparent color does. And I actually seem to remember somewhere that the background color is basically not used anymore in modern GIFs. So probably not to do with that. But it could be our transparent handling that's not being done properly. No, because you see, the way it's done, the bits that start off with this transparency are parts that are pretty homogeneous. Am I missing drawing a frame? Is there an initial frame that I'm not getting to? There's this scribble kind of thing in the image that's just there. It's just there in the image. I don't know why. But you'd think that that should be transparent after the first frame. First frame draws it, and then all the others should just be transparent. So hey, you know, this hasn't actually changed. So I find the transparency thing a bit confusing. And you know what? I'm just going to ignore it for now. Just going to ignore it. So, yeah. Instead, let's look at performance. Let's look at fixing some of our performance problem. And this will also help with animation. So one of the things that's happening here is that when we go through, we read the image, we read the actual image data. We'll do that here. We read out all the bytes, we decode them, decompress them, and then, here's the decoding, and then we immediately draw them to the screen. And we do that for each frame. But obviously what we really want to do is we want to decode them and store them somewhere so that we can use the same decoded frame over and over again. Every time it comes back up, we can draw it on. And this means that while it might still be slow to decode with the code we've got at the moment, drawing it on the second time through and after will be much, much faster. We've already decoded it. We've created a canvas. We're just drawing that in now. In fact, we don't even have to create a canvas. We just need this data because we can, or perhaps an image data object. We basically just need the bytes of the color, the bytes to set, and then we can use exactly what we do with image data, where we copy, this context.putImageData. So what we need is a new image data object for each frame, and then in our request animation frame loop, we're just going to use the correct one. So I'll have one for each frame. We'll just use the correct one when we get to that frame. So let's start with that. So in our GIF class, we're going to have some frames. Let's just add this here. Start frames equals, just going to be an array. And this is going to contain our image data, or perhaps the bytes. I don't know. So the image data object does have slightly more information about it. So storing lots of them might be might take up slightly more memory, but the alternative, where we store an array buffer, we can then use a single image data, and then we just set the array buffer that it has to be the same as the array buffer that we've got, and that memory copy may be expensive. So it's a bit of a toss-up. So I'm going to just use. I'm just going to use the bytes for now. How about that? So here we're going to create a new array. We'll call it frame data. It's a new uint 8 array. Let's make it a uint 8 clamped array, because that's what the image data actually gives you. And we know the size of this. This is pixels dot byte length. Byte length. Yes, we get 1 byte, 1 index per pixel. We're actually going to multiply this by 4. Is there a separate length? Yeah. I'm going to multiply this by 4 because our pixels actually have 4 values: the red, green, blue, and alpha. So here, instead of actually drawing this stuff out, instead of writing to image data.data, we're going to instead write to into frame data. What to do about transparent pixels? That's a great question. Is a great question. In the case that we have a transparent pixel, because here we're decoding all of the frames, we know that we're doing them in order. So what we'll do is we'll say that each of these, if, we have to make sure that we already have at least one frame in order to copy it from. Else if this dot frame frames dot length greater than 0. Can't type today for some reason. Then what we're actually going to do is pull this out of the previous frame. So this will be this dot frame. So I'm not doing the calculation each time. So it's this dot no, this is last frame. This dot frames. This dot can't type. This dot frames dot length minus 1. And so for each of these, we're actually just going to copy it over. Just get that. So I can do a little bit of cursor magic. That's the last frame. Trying to do this with the cursor, multiple cursors. Sometimes it works great. Sometimes you just save yourself a whole bunch of time, and then sometimes you spend so long thinking about how to do it, you might as well have just typed it out. Yeah. So we just copy in whatever is in the last frame. The reason why we have to do that here could this be our problem? No, because previously when we were writing into the actual frame data, into the image data buffer, the value from the last frame would already have been there from the last time we wrote it. So that's not our transparency issue. Yeah. Okay. Seems good. So now we're going to, at the end of this, we'll say that this dot frames dot push frame data. And do we need to return this stuff? Interesting. No, I don't think so, because we already... Oh, interesting. So, yeah, in the case where the frame isn't being drawn over the whole of the canvas, this will be wrong. We'll get a frame data that's not the right size for the canvas when we come to draw it. And obviously our test GIF doesn't have this issue, but that doesn't seem any reason not to handle it. So instead, okay, we already had that problem. We weren't calculating the X or Y. We weren't offsetting them. We were just drawing into the wrong place. We already had that bug, and I'm willing to just work to the GIF we have. I appreciate that's not great, but we do still have. Do we have an issue? No. So instead, I'm going to put in like an assertion. I'm going to say I'm going to assert that. Where is it? Oh, here we have these X and Y. I don't think they're ever used anymore. So yeah, we used to deal with it when we were drawing rectangles to the screen for everything. So here we say if image left position is not equal to 0, or image top position is not equal to 0, or image width is not equal to this dot width, or this dot, or image height is not equal to this dot height. Then throw a big fat error. Throw new error. Not yet implemented. Frames that don't fill the canvas, and let's use backticks so we can use our single quote there, or apostrophe. So we'll just crash out if we get a GIF that's like that, and we could fill this in later if we were going to carry this on. Yeah, and we have a reasonable idea. We've made a note. We've made a note of what it is that we haven't done. That still works. That surprises me. How does that still work? Oh, you know, it will be because without DevTools open, it's going to the cache. Yeah. Here we go. So we're going to do all that, but we're not going to draw anything. And then at the end, we are going to, well, each frame also has some information about its, how long it stays on screen. Interesting. So as well as transparency, I'd forgotten about this, the disposal method. We need to know this stuff about the graphic control extension for each frame, don't we? So each frame is going to need more information. So how's about what we do is we say that a frame is going to be an object with a bunch of information in it. And when we parse data, we're going to say okay, let's have a look at the at our spec, because at the bottom of here somewhere there is the grammar, and I think that the very last thing about any individual frame is the frame data itself. Where is it? Here we go. So we have a graphic control extension followed by a graphic rendering block, and the graphic rendering block is the actual image stuff, and the image data is last. So our information about each frame we read in the graphic control extension, which has the transparency information and has the which could be different from frame to frame. There's a thing to think about. That might be why it's not working too. So it has the transparency information, it has the how long the frame should stay on the screen, it has the disposal method, which we'll get to in a bit. So every time that I read an image data, I can sort of increment the count for frames or whatever. I can say that. So in everything, I work on what is the current frame somehow, and then in the image data, I say, "Oh, we'll move on to the next frame." And at the end, I need to delete frame? No, I need to check that the frame has been written to, and if it hasn't, delete it. Okay. That's fine. So here we're getting the current frame. I'm already doing that here. Where is it? Ah, it's last frame. Okay, I think we need to store an index. So the frame we are working on is frame 0. I'm also going to say that we start with an empty frame. A frame with nothing in it. And we'll create a class for frames. So I'll have a data object for the actual bytes, and then what do we get out of the graphic control extension? I mean, I think these are actually the only things that we care about. But block size here is actually just how big this block is. We don't actually even need that. We just need to read it off, right? But these things are to do with the frame. I'm lost in the code. Here we go. Ugh. Okay, fine. Just have to do these ones. Sorry, that's me trying to be clever with multiple cursors again. And these all need to equal something, some good default. What have I done? Let's say 0 for me, transparent color flag. So that's a boolean. That's going to be, let's say, false. User input flag. Not quite sure what that means, but that sounds like a boolean. Disposal method. Index delay time. We'll say that the default is that. That's one frame length on a 60 Hz monitor. And we can tell if the frame has been completed if there's image data in there by just looking at whether the data is null. So I like this. I like this. This is current frame index, I guess. Now, where do we deal with frames? So logical screen descriptor is global. Image descriptor is not. So this is going to be these names are getting out of hand. Image bytes is no longer really the bytes for the image. That's confusing. So we're going to say so the frame is this dot frames, this dot current frame index, and const last frame equals if this dot current frame index is more than 0, then it's this minus 1. And how do I turn on word wrapping? It's driving me crazy that I can't see all of my line. So it's that, or it's null. Why are you wrapping to there? That's not good. So we've got the frame, we've got the last frame, so this is actually going to be frame dot data, in fact. No, not const anymore, just frame dot data. These are frame dot data. Last frame, that's actually what we called it, but it's now last frame dot data. And we no longer have to do this push. Instead, what we're going to do is we can say this dot current frame index plus plus. We also need to create a new frame. Start frames. Push new frame. So there is always a frame object, even if it hasn't had anything set on it. There's also a frame object at current frame index. Extensions, application extension, that's global. Graphic control extension. So here we're actually writing, we don't need to return a result. Instead, what we're going to do is we're going to say that const frame equals this dot frames this dot current frame index, and we're going to say that for each of these we're just going to set the value. Ugh, really can't type. It's the same keyboard I've been using all day, but right now I can't type on it. There we go. Oops. No. Yeah, there we go. So we set all of those values. Awesome. Here, interesting, we set these globally. I need to get rid of them globally. Because they are per frame. Oh, no, I've already got it. Transparent color flag, transparent color index. I'm going to move them next to each other so it's easy to see. I'm going to get rid of this. Transparent. Transparent. Let's find anywhere that we mentioned that. And fix it. So that's good, that's good. No, get rid of those, we don't have them globally. And then here, instead of saying this, it's going to be, oh. I don't know what is wrong with me today. Can't type, can't use a mouse either. This is going to be frame. Dot or whatever. Oh yeah, I'm pulling out last frame here, but no need. I've already pulled it out here, speculatively, as it were. And in here, it's just going to be if there is a last frame. Okay, so now we're building up a bunch of information about each frame. Let's give that a whirl. Obviously nothing will draw anymore, but we can see what data we're getting. So we can see at the end of here that this dot frames. Oh no! Yeah, light's gone off. This dot frames is length of 1, and nothing has ever been set into it. That is super disappointing. Oh no, we haven't parsed any data yet. Okay, phew. Good. Right, so at the moment it's parsing all the data while it draws. So let's turn that off. So while this dot parse data. And we'll just comment this out for now. But at the end of here, this should read all our data, and yeah, and at the end of there, we should have everything. So it's taking its time because it's parsing all the information, which we already knew is a little slow. So here we get 46 frames, which sounds good. They'll have a bunch of data in them. It's all the same size. Delay time 7. Disposal method 1. Transparent color flag true. Transparent color flag false. So yeah, some of the frames don't use transparency, and that will be why we're getting why we're drawing it wrong. And in fact, I know the very first frame does have the transparent color flag. Crazy. Unless we're supposed to draw the last frame first or something like that. I mean, because it's the last frame that doesn't have the transparent color flag set. Interesting. Well, we need that. So now we're getting all this data. Let's add in our drawing loop. And for now, we're going to ignore any question of timing. We're just going to draw one frame per frame. And here we want to say that the image data set. Okay, now I'm going to have to look this up. Array buffer set. Typed array.set, sorry. So we're copying values from array or typed array. So the value, so okay. So this is the target. Dot set dot frames. This dot current frame index. Dot data. And obviously here we need to set the current frame index back to 0. We have to increment it. And then we have to just make sure that we wrap around at the end. So in fact we're going to say this dot current frame index equals, and it's current frame index plus 1 modulo this dot frames dot length. So if it gets to be the same as the number of frames that we've got, it'll actually loop back to 0 and just keep going. Sounds promising. Let's see what actually happens. Nothing. No. Oh, no, something. Just slow because it had to process all the data first. Well. And then we stop. Interesting. Something happens in the console. It cannot read property length of null. Right, okay. Now that makes sense. That makes total sense. Because as I said before, we're going to add a frame to the end of the list that isn't a real frame. So we're adding it at the end just in case we go through again and we need to start adding stuff in at the graphics control thing before we put in the image data. But the image data is the only part that we know we're going to get. So once we've parsed all the data, we just need to say if this dot frames this dot current frame index dot data equals null, and this dot frames dot pop. Let's get rid of the last one. Should do it. Awesome. So, well, let's go for frame timing then. So, what we're going to do is we're going to have a value here which is like, let's just say that it's the frame timer. We'll set it to 0. Whenever we draw a frame, we're going to say that the frame timer, we're going to add some value to it. We're going to add on the let's pull out the frame so we can refer to it more than once. So it's going to be frame dot delay time times 10. Yeah, it's in hundredths. And then what we're going to do is we're going to, at the beginning of every frame, after we've requested an animation frame, we're going to say if frame timer is less than 0, do the drawing and update the frame timer. You know, we add some more on there. We're also going to do frame timer minus equals elapsed. Last frame, start that at 0. Const current, no, time, last frame time. So we're going to get confused between current frame and current frame. So current time performance.now, which gives us a high resolution timer. Elapsed is current time minus last frame time. And then we need to set last frame time to be current time, so that the next time through we're using the updated value. So we tick down the frame timer each time. This means that we will, on some frames, so let's talk about what happens here. So we come in first time, frame timer is 0, last frame time is 0, current time, performance.now. Performance.now gives us a timestamp from when the page loaded. you know what, last frame time, let's make that performance dot now, because we set this after everything has loaded, so we won't skip a whole bunch. If we set it to 0, then what would happen is the first time we came through here, we say current time is performance dot now. Let's say it took 5 seconds to decode the GIF. So this would be 5,000. Last frame time would be 0. So the elapsed would be 5,000. Frame timer goes to minus 5,000 straight away. And then every time through, so we add on 70 each time. And we're just going to be doing 1 frame per frame for ages while we catch up. So we should start it at performance now, so that we only have the amount of time that has actually passed between here and drawing the frame, which in the first instance will be very close to 0. Probably not actually 0, but very close to 0. Okay. I think that might work. So wait for it to load. Aha! That animation seems a bit more reasonable. Let's look at the actual original cat GIF. Okay. Yeah. So that looks about the right timing. Did you see what happened there? While we were not looking at it, request animation frame is not firing. It is not firing in our tab because the tab isn't visible. So what happens is that the last frame time is still whatever it was, but as soon as we come back and the request animation frame starts firing again, our current frame time is going to be really far ahead. And this is exactly what I said would happen if we set the last frame time to 0 in the beginning, is it would come back and the difference is huge, and we're just going to play 1 frame per frame for ages until it catches up. So yeah, and then it catches up and it works better. I'm a little disappointed that transparency hasn't been fixed by the code we added in to make the transparency come from the individual frames. But I guess we knew that, didn't we? Yeah. Because only the last frame doesn't have a transparency index. Okay. Let's work on making the animation stop, or at least the animation timers stop when we're not visible. So we're going to look up an MDN, we're going to look for page visibility. Page visibility API. Visibility change, that's what we want. So on visibility change, that doesn't seem to have a lot of information, but I guess we can then use the page.visibility state to work out what the current thing is. So that means hang on, what's the, so it's on document. So here where we're actually drawing, where is that? Yeah, what I'm going to do is we're going to have a little function dot add event listener, visibility change. It's just visibility change, all lowercase. So we only really care about the case where we become visible. We want to reset the timer whenever that happens, right? Or should we use document.hidden? That's a great question. Yeah, this looks like they want to use document.hidden, but I'm not sure of the difference. So document.hidden, oh sorry, not document.hidden. So if visibility has changed so that we are not hidden anymore, we just do this. We reset that timer. So now we should be able to go off the page and wait like 5 seconds. Maybe give it a bit longer. Yeah, that should do it. And it did not speed up and go crazy. Awesome. Okay. So we have our animation running at the correct speed, and we have frame by frame information. There are two things that are troubling me. One obviously is this bug, and I'm going to look at something called the disposal method because that might be what's causing the trouble. And the other one is just this is taking a really long time to decode. A really long time. With the GIF decoder built into the browser, the frames will actually start playing when only a few frames are ready, and this should actually already support that. You know, this should actually already support that. Where are we? As long as we have one frame, this will work. So we can call draw here to start this loop going. No, because we never yield from... so here where we're doing the parse data, that's never going to yield so that a frame can be drawn, is it? Shame. Yeah. It would be a fairly significant rewrite to make that work. Instead, we may look at making the decoding faster. I have a couple of ideas on that. But first, let's look at this disposal method, which I have mentioned several times. So here, not that page, continue, and then continue, disposal method. So if you weren't here last week, I found this awesome piece of documentation called What's in a GIF, which is actually part of the documentation for the GIFlib library that describes how a GIF works. And one thing that I noticed in here is this little description of disposal method. Disposal method specifies what happens to the current image data when you move on to the next. We have 3 bits, which means we can represent a number between 0 and 7. Now, a sample animated image has a value of 1, which tells the decoder to leave the image in place and draw the next image on top of it. Value of 2 would have meant that the canvas should be restored to the background colour. Value of 3 is defined to mean that the decoder should restore the canvas to its previous state before the current image was drawn. I don't believe this value is widely supported. Fair enough. So you kind of skip a frame, so that when we were doing this, where we're looking at last frame here to get the data from, we would actually use the frame before it. We'd say -2 here. But sadly, that actually doesn't seem like it's going to address our transparency issue, because I think we're already doing what number 1 says, which is leave the image in place and draw the next image on top of it. That's exactly what we're doing. And I also think that's the only value we're getting. So if we, if I stick a breakpoint in here, find this thing of, there we go. So in our frames, the disposal method is 1. Disposal method is 1. You know what? Let's be a bit more clever here. Conditional breakpoint. Well, we'll break if frame.disposal method is not 1. Let me just set it going. Again, the frame timer is wrong because the visibility didn't change. It was just a pause. But you can see that we're playing the whole GIF, and this breakpoint never becomes true. We never get to the point where frame disposal method is not 1. So that is not our problem. Let's check on performance here. Let's just check that copying that memory over the bytes each time is fast. Yeah. Though I think Chrome is slightly confused about performance here. You see how it kind of, the frame rate is sort of stepping up and then goes down and then steps up. I think that's the time. Yeah, interesting, because we don't draw anything on some of these frames. The GPU never does anything. So you can see here we get the request animation frame fired. Request animation frame fired. And this one, our timer has ticked down enough that, oh, it's time to actually show a frame. And so it actually does drawing, and then Chrome recognizes, oh, you know, a frame was drawn there. So it's giving us this 50.3 milliseconds frame, but actually we drew, well, we had an animation frame 3 times during that. Well, here where we get 4 in 66 milliseconds. So because we're doing something slightly unusual, Chrome doesn't think that we're hitting our frame target. I'm pretty sure we are, because this looks pretty sparse. We're doing this 60 times a second easily. Okay. This talks about delay time, which we're already dealing with. So what do we want to work on? What do I want to work on? Well, I'm going to make this. I'm going to make this window full screen. I now have to wait for the delay on the screen to be. Yeah. Okay, this is what we'll capture. Good. If I do that, yeah, it captures it. Something that I realized I had done early on was I had made the mistake, committed the sin, you may say, of early abstraction. What do I mean by that? I mean that when you're writing code, you don't really know what you're going to keep. If I take, let me say that again. So let's say I'm writing some code that is going to draw out a menu. So let's say I'm doing a game, and so I actually have to draw out the items in the game's menu. And so you see, okay, there's like 5 items, and it's drawing a piece of text at a location on the screen, and they each need to be highlightable, and they each need to have something that happens when you click on them. And so you start off and you make an array which has a string for what the text is, and it has a Y position for where on the screen it should go, and it has a function callback for what should happen when you click on it. And then you create a function that takes that array and it loops through it, and it goes ahead and draws it on the screen. And then you realize later on that you want to do something very subtly different for every single one of those lines. You would actually have been better off copying and pasting the code 5 times, having all of the strings and function calls as constants, and then just tweaking them all in place. After you've got to the end, you can see whether an abstraction would help. If they are all exactly the same after you have created it, sure, put that in a function, put it in a loop, because you are doing the same thing for each one. But in the case where you actually had to do something slightly different for each, perhaps some of them are actually multi-option things where you tap left and right to select something, and perhaps you have dividers that are like don't do anything, and you just want to draw it without actually being selected. That kind of thing. Perhaps some of them have confirmation, and some of them just take you straight to whatever it was. Yeah, in that case, the abstraction didn't help you. The abstraction actually hindered you. It got in the way. Because either your function has basically a whole bunch of different cases in it, and you're specifying all sorts of data in this data structure, or you go back to just imperative, here are the 5 different things that happen when drawing out this menu. And I have done that here. I think that my abstraction of the LZW decoder has not helped. I guess it helped a bit. It helped me get my head around things. But really, this code is only called from one place. It doesn't need to be abstracted away. It lives down here where we decode the pixels. Because you see, what we're doing here is we're reading out bytes from these subblocks. And in fact, reading the subblocks, parsing the subblocks, is also a mistake here. So we go through, and I look at the subblock, which I know is going to be here. I know I'm getting a subblock, but it may be 0 sized. And I read through all of those bytes into an array buffer. And then I take those bytes and I push them into a big array of subblocks. And then once I've got to the end of all those, why am I dealing with subblocks? Okay, I don't push them into subblocks because that never gets used. Well done. But I go loop through every single byte of that and push that into this image bytes array. So I've read out all these bytes individually, one by one, for the subblocks, and then I'm going through them one by one and pushing them into a new array to make a bigger array with all of the image bytes for the whole frame. And then I stick all that through LZW decode, which is going to go through this image bytes thing and pull them out several bits at a time. So it's going to. So I take my array buffer, I copy it into another array buffer, and then I read through the bits one at a time. Why don't I just read bits from the stream originally? Good question, right? That is what I should have done. So even though that might look like bad code, that I'm just going to make this function which is already pretty big. I'm just going to make, like a couple of nested loops maybe, and just put all of the logic into here. It will probably perform way better because I'm not putting in an abstraction for me that isn't performant. I guess that's the other thing, is that abstractions, where an abstraction costs performance, that is always bad. What you've done is you've made life easier for yourself while making life harder for all of your users. And if you write something that is used by even 2 people, then that abstraction was not worth it, because your users are paying a price every time they use it for something that you only wrote once. Does that make sense? Yeah. There's a little rant, a philosophical rant. So yeah, I reckon that I can make this faster by decoupling things. Another thing that I think I can do at this stage. No, I was thinking about splitting this into multiple files. I don't think we're there yet. That's another abstraction that isn't necessarily good. I find it a little difficult to move around in this file. It has become a bit long. We're at 400 lines. Oh, I was looking for this in the spec earlier. I didn't remember it was even here, so it's probably time to get rid of that. So parse subblock, I believe, is called from 2 different places. Yeah, in the application extension we use it. So I don't want to get rid of that function. I'm just not going to call it from inside the part where we decode the graphics information. So that's the first thing we're going to do. What do we need to get rid of? So here, so these need to be lets, because we're going to overwrite them. So this is going to be subblock length. And what are we doing? So we did call it data, right? Oops. Size and data. Oh, we can just call this size, and then it's the same thing that we were getting before. While size is not equal to 0. Good. Oh, right, yeah, okay, that's what we're going to do. Here, instead of getting, we're never going to get this data. We're not going to get a byte array of the length. What we're going to do is, I'm going to say let no. So bytes remaining. This is how many bytes we have left in the current subblock. While bytes remaining is not 0. Yeah, okay, this is, I'm trying to think about the logic of this. So, I need to go through and read some number of bits at a time. So let's move this up here. Oops. Pixels we're still going to deal with, are we? No. No, I don't think we are. We're not going to loop over the pixels because we're not going to get all the pixels in one go. We're going to get them one at a time as they come through. So we don't need to create this pixels array at all. We don't need to create an LZW decoder. Then I'm going to leave that in just for the moment to remind me to put the min code size +1 as the number of bits we read. In fact, is min code size used for anything else? No. So we're just going to say that it is +1. And then we can get rid of that. We don't need image bytes. But again, I just need to remind myself what that was while we work through this code. Okay, so while bytes remaining is not equal to 0, I'm going to say that... okay, so this could be block bits remaining, and it's going to be this times 8, because I get to read. I read how many. I know how many bits that I'm reading each time, not how many bytes. So rather than trying to figure it out, like, you know, where am I through the bytes and whatever each time, we'll just work entirely in bits, and then I can remove that number of bits each time. If we get to the end and what happens at the very end? Is the data padded? That's a great question. So what currently happens in the LZW decoder when we get towards the end? Oh right, we get an end code? No. Right, it doesn't so it doesn't actually matter what happens. So if let's say we're getting 7-bit codes, if the number of bytes in our block doesn't give you an even division of 7 bits, then it just means that the bits remaining at the end of the first block will go on to the beginning of the second block. It's just what will happen. So it's literally just, we only care about just keep reading those bits. Just keep reading those bits. This is more complicated than I thought it was going to be. Messing with my head. Right. So this while loop isn't actually going to be on block bits. We'll have to deal with that so that we know when to move blocks. But actually, the while loop is based on this. You know, have we reached the code, the end code? So I'm going to put a big delimiter in here to say decompression, so that I can see, you know, this is the part where we read the image to script image descriptor, and then this bit is decompression. So, min code size, done. Dictionary. Interesting. Isn't that in the clear rather than... Sorry, talking to myself again. I've copied the clear bit, but I have not copied this, the constructor. So clear is a thing that I might need to do multiple times. So I will stick that in a function, but it's going to be a much smaller function. So not a much smaller function, it's going to be a local function. So that's going to be that. We already got that. Clear code is that. Here we need to call clear at least once. This stuff we ain't gonna do. What we're going to do instead is we're going to read the bits directly. So again, I might take the get bits part here and de-abstract that. Now, as I say, I mean, obviously this is going to look pretty messy, you might think. We don't want buffer or data view. We do want partial and bits remaining. But there's at the end there's an opportunity to abstract again, but then we'll know actually what we're trying to do. So we'll have a getBits function. Doesn't want to be at this. Oops. Oh yeah, we need a get byte. Interesting. Not quite sure how we'll manage that, but we will. These are going to be lets. Because they are going to change. This is going to change. Okay, I think I already have a slightly better idea of what the abstraction is going to be at the end as well, which is good. We don't know that for certain. Is that this while loop? Yep. So what is going to happen here when we're doing our output? We don't actually want to bother writing an output. That is no good to us at all. Output index. Where do we use that? Got it. So we pass in the output array where we're going to write to. What we're going to do instead is we're just going to write straight into our frame data, right? So this seems like a reasonable abstraction. This is going to be a function up here, which is going to be write pixels. It's going to be our indices. That's a function. I really need some proper linting on here so it can tell me where I've messed up, but okay. So here, instead of writing to output, instead what I'm going to say is, let's cut that code. We're going to say write, what do I call it? Write pixels, write pixels, write pixels. And then what do we got? Current. Let's get rid of a lot of this is. Okay, let's do that properly. Awesome. So here we will write out the pixels as we get them. And write pixels needs to be a loop. So it's going to be for pixel. Let's call this pixels. Pixel of pixels. Where are we writing to? So we need that index equals 0. So that as we're writing to each of our indices, we just write them out wherever they are. And keep incrementing. Okay. So this is our main loop now. This is actually going to do the writing. The only thing we need to do is change how we're getting the bytes for reading the bits. That's what we need here. Frame update. Okay. So we can actually get rid of all of this. We just need to remember to do this. So we just need to remember to pull out the block bits. So, how are we going to get bytes? Pretty easy, actually. So this actually is going to be this.read.get byte. It's exactly what it's going to be. It's going to be that. going to read off the original stream. We just need to very slightly change things here. To use this block bits remaining. Yeah. So okay, let's change this to be get block bits because this bit's I just want to pull it out into a function so that I can think about it easier. It's all I'm really going for here. But again, possibly an early abstraction. But certainly an easier one to get rid of. And not one that should actually really improve, decrease performance. So get block bits. What was this originally? 8. No, okay, yeah, got it. So I can make this get block byte. We always read 8 bits, a full byte from here. The only thing is, and in fact this can be block bytes remaining. We don't have to deal with bits at this level. But we're no longer going to load them all up and store them in an array. We're just going to read them one at a time. The only important thing is that if block bytes remaining equals 0, then so I guess we have to remember to decrease that every time we read. So if we've got a 0, then what we're going to do is we're going to read a new. Well, first of all, we're going to check that we get a 0, because after every block we get a 0. So we're going to confirm that. Do I even check for this? Terminator. Yeah, I check for the terminator. They're terminating 0. In there. Oops. Just a little check. We don't really care that much. I mean, if it's a bad GIF, it's a bad GIF. But this just lets us see what happened if we're running our code. So we read the terminator, and then we read the new size, so the size of the next block, which is going to be this. Read a new byte from the stream to be the block bytes remaining. And so this is block byte now. I think this might work. I think this might be the correct code now. So we no longer load everything up into various nested arrays. We load the bits straight out of the original array buffer and write out indices straight into the frame. The only place that we are going to carry on building up an array is here in the dictionary. The dictionaries are still going to do that. And this concatenation is still going to be slow. So, 2 questions. Does it work? And was it worth it? And I don't know the answer to either of those. Does not work. That's fine. Index. Let index equals 0. Okay, we can get rid of that. Good. Fine. Reader is not defined. Okay. Reader. Reader.getBits. Oh, I've... Yeah, okay. Yeah, fair enough. That's just getBits. I removed a this dot earlier. That's left hanging over. So now code size is not defined. No, that's true. I've accidentally renamed it, I think. So code size equals initial code size, which I've actually called it min code size. So I just change min code size to be code size, and that will fix everything. I'll fix that. Dictionary is not defined. Okay, dictionary. Oops. Const dictionary equals that. That needs to be outside of the loop. Oh, and then I need to need to clear the dictionary, so I need to make it a let, so that I can set it back to that in the end. Whenever we clear. Pixel is not defined in right pixels. For const pixel of pixels. Tons of copy and paste errors. Frame is not defined. Where do we say frame? All over the place. But I don't define them until later. Okay. So this goes up to the top here too. Technically part of the decompression. Pixels is not defined. Oh my word. Pixels. Okay, fair enough. Pixels.length times 4. What do we have before? We were setting the length of pixels to be something. Pixels was the width times the height times 4. Which is what it should be. Width times height times 4. Subblock did not terminate where we expected it to. Okay, so after all that, we have reintroduced, probably, some decoding bug. Block weights remaining equals 0. Oh. No, equals 255. Block bytes remaining gets to 0. Terminator, we read a byte, and it's a 255. Did we read one too many? Is that what happened? Is that what happened? It might be. It might be what happened, that we've read too many bytes. Oh no, that's not what I wanted to do. Okay, so here position is 117346. In our buffer, oh no, can we not see the information from the buffer? No, that would be useful. In our watch, we're going to look at block bytes remaining 255, 254, of course. Probably do this a better way. Let's do an edit breakpoint for block bytes remaining equals 2, just in case. Okay, so block bytes remaining equals 2. So here we're going to read out a value, which is going to be a 60. Okay. We come back through. Block bytes remaining was 2. It has now been reduced to 1. We read a value. It's a 147. Block bytes remaining was 1. It is now 0. We read a value. It's a 43. It is not the 0 that I kind of thought we'd get here. So now block bytes remaining is 0. So when we come back in here, we go through and do this check. We'll load up the terminator. It's a 255. I don't get it. Oh, yeah. Okay, no. I'm an idiot. I'm an idiot. Complete idiot. Subblocks don't have a terminator. I've just invented that. I was thinking about the wrong thing. Because they have a length. They don't need a terminator. They don't need a thing to say, hey, this is the end, right? Is that correct? So instead what we should find is that this is generally always a 25, always gets set to 255 until the very end. Yeah, because they're all the maximum size they can be. Okay, now we have a different problem. Unknown code was not next in sequence. Can we get rid of that? No, I guess not. What's happening when I clear now? Set next to be end code plus 1. Yeah, that's fair. Oh, just for my own sanity, so I don't make that mistake again. I'm going to put the call to clear just after clear, after the definition, so I realised we'd call it straight away. Remember that I thought this was actually getting run before we cleared, but it isn't. We don't call this until further down. Code, output index, which we don't actually need anymore. Let's go through. We had in here sample1.gif. Let's go back to that just so we can confirm that it's confirm the values that we're supposed to be getting out. I do hope this speeds things up now. This will be pretty embarrassing if I get through to the end of here. Unknown block type 0. Oh my word. Interesting. So we come through here, and this is before we hit the error. Good, that means the error really is in the part we're looking at. Width is 10, height is 10. So we need 40 bytes. Sorry, 400 bytes. Okay, code size is 3. Yep, that's what we expect. 22 bytes remaining in the block. Yeah, that sounds right. Yep. Where is it? Here is the image data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, plus another 3, which are the code size and something else. Code size, the block size. And a trailing 0. That very much looks like a trailing 0. Interesting. Maybe I'm wrong. Maybe I'm wrong. So let's go through initial code size, the code size. We're saving that so that when we clear we can set back to initial code size, which we are not doing. Never setting it back to the initial code size. Isn't that code size equals initial code size? Let's just run it. Let's see what happens. Not a lot. We're still getting unknown block type 0. Okay, well let's just carry on then. So we get to the start of our loop, and the first code that we've read is a 4. Let's double check this. First code that we read is a 4. Yes. Which is a clear code, so we clear. We get a new code, which is a 1. Yes. We'll build a dictionary. I'm just going to assume that's basically right. We write pixels here, so pixels is just a 1. Great. So pixel is 1. Look at the color. Red, green, and blue. It is a bright red. Frame data has 2 red pixels in it now. Is that correct? code 6, code 7, code 8. Code 9. That doesn't seem right. That does not seem right. Let's go in here and just watch what code is. 4. Whoa, 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 whoa. So the very first time it's a 4. And then we come back round again. Okay, 1. Let's move this where I can see what the results should be. 6, 6, 2, 9, 9, 7. This seems pretty reasonable. So maybe what happens when we get to the end? We never get to block bytes remaining equals 0. Because we hit the clear code first. Right, okay, there are only 22 bytes. So block bytes remaining 21, 20, 17. See what the last one we see is. 5, 4, 3, 2, 1, 0. So we do see 0. We're returning a value of 1. The last byte is a 1, apparently. Let's check that out. On this page, we get to see what the actual data is. The last byte is a 1. Yep. And then turns out the code equals the end code. We're done. We never read the next byte. And then I don't know what happened. Why did that go wrong suddenly? Yeah, so we're getting to the end here, and it looks like we've successfully read the image. So we'll look at the frames. So frame 1, the data is null. This is the frame we've just added at the end. Here we have 400 pixels. We have red, yellow, blue. Is that right? Oh no, okay, sorry. It's 4 bytes. So that's red, 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 blue, 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 red, blue, blue. Does that sound reasonable? Sounds similar-ish to what we've got here. And I may obviously have been reading that wrong. So maybe it does have a terminator. Maybe there really is a terminator byte to these, and I was just reading it wrong before. I'm going to have to look in the spec, because I've obviously made a mistake in moving this code over. And I should have just looked at the spec first, shouldn't I? There you go. Instead of guessing based on what I remembered. Image data subblocks. Color table. Let's find subblocks. subblocks. Has the block size followed by the data values. Right, so this is something that didn't come up when we were reading all the data out before, because I read all of the subblocks first into an array. Now that we're doing it piece by piece, the very end of this data has a data subblock of 0 length. So I need to keep reading. I need to, at the end of this function, keep reading until I get to that 0 subblock. Yeah? And my buffer reader, did I add a skip? I did. So at the end of here, we're going to list.reader.skip block bytes remaining. I'm going to skip any, and then while block bytes remaining, while block bytes remaining is not 0. We're going to skip any bytes remaining, and then we're going to set block bytes remaining to be whatever we get by reading the next byte. So that should always give us the length of the following block. And this will work because the end code has to appear in a non-zero length block. Okay? Right, no, this does have to be outside the thing, in case there are 0 bytes remaining in the current block. So what we're going to do is, we're going to say, okay, so we get to an end code, which may or may not be at the end of the block. If it is at the end of the block, block bytes remaining would be 0, but it must have been in a non-zero length block. Does that make sense? So there must be at least one more block left to read. Probably, if the GIF has been created correctly, it will just be that 0 length block to say, hey, actually, we're done with the image data. But it might not be. So we skip any bytes that are remaining, just in case there are some bytes remaining in this block. We read how many bytes there are in the next block. We read a single byte, give us the length. If that is not 0, then this while condition is going to come up, and so we skip everything in this block and read a length again. And we keep going until we get to a 0 length block, at which point it will drop out. So this allows us to deal with the common case, where we're going to come through here, block bytes remaining will be 0, because we're at the end. We'll read this, it'll be the 0 length block, done. Okay, leave. But if we do get a GIF that follows the rules, but isn't very well put together, this will then continue reading the rest of the blocks. This is all good. Okay. That is not correct. But it's not correct in an interesting way. Can I not zoom any further? There we go. Zoom, zoom, zoom. Okay. Clearly not getting enough colours back. So we're reading through all the data, but when we write out our pixels, that's not giving us all the pixels we need. So let's have a look in write pixels and see what we're feeding it. Pixels is a 1. And then it's a 1. And then it's a 1, 1. You know, I should do this at the end here, just to make sure that, because I think if I put it on this line, then it will come up each time through the loop. So, we're going to 1. We'll get 1, 1. So 3 1s so far. What are we supposed to get? 1, 2, 3, 4, 5. 5 1s altogether. We've had 3, we should get another 2. Next time through we get 2 1s. Brilliant. Now we should get 5 of some other value. I'm guessing that's a 2. So we've got 1, 2, 3, 4, 5. Okay, so now we should go back to 5 1s again, right? We have 3 1s plus 2 1s plus a 2. Yep, great. Now we should get 4 more 2s. That's 3 more, so we should get 1 more 2 and then 3 1s. 1 more 2. 4 1s. So this is where we've gone wrong. This definitely shows something has gone wrong. And it might be the way that I'm building the dictionary. I might be doing that wrong now, because I have played with this code a lot. You know what I'm going to do before we do anything else? I'm just going to check something. I'm just going to put this back to be the cat GIF. So we know it's decoding the image wrong, but it should be reading the file correctly now. If I go through here, it's going to decode the file and then show it wrong. Yeah, there we go. So here's what I want to do. Did I improve anything? Did I improve anything? Maybe. A resounding maybe. So we start. Oh no, that's garbage collection. When do we start drawing? Is this right at the end here? I don't see. I don't see where the CPU is really getting used, except beginning here. So receive data. I'm a bit confused about what this is telling me. It didn't seem to be showing me anywhere where it drew. Ah, it's because it takes longer than 3 seconds. I think that maybe, just maybe, I have not improved anything anywhere, which would make me sad. That is pretty crazy. I mean, where is the CPU time for decoding the GIF? Where is it? I don't see even a little bit of a chunk of that here. So what I'm going to do, if I refresh, then the performance thing will start and it will record exactly 3 seconds if I'm on the performance pane. That's not what I meant to do. So here's what we're going to do. I'm going to go to a different tab. I'm going to refresh. I'm going to go here and I'm going to click record. And I think the initializing the profiler didn't kick in until it was already drawing. Perhaps. I'm really super confused. There doesn't seem to be any CPU time here devoted to decoding the GIF. Compiling the script, sure. Evaluate script. Total time 5.8 milliseconds. Begin, fetch, run microtasks. Super confusing. If I stare at it long enough, I think I can still see the brush. I can see the brush. So the way we're building our dictionary is wrong. And I'm not quite sure how to evaluate this performance now, because the performance tab is giving me garbage. So what I expect to see is that if I refresh with this on, I expect that the recording should show that the GIF loads, and then the CPU is just nailed, just like 100% by the decoding. Oh, maybe it's actually going to do that this time, since the profiling doesn't seem to have just stopped naturally. No, this is just doing frames. I didn't actually refresh there, did I? Just click record. So yeah, the cat GIF loads, and nothing is happening. Here's the main thread. Blank. Completely blank. So we've got some received data, finish loading. Nothing happens. We have the GPU doing something roughly every, what was that, 30 milliseconds? 40? So it seems like it's rendering the page. And we have these garbage collections, but it's not telling me what caused the garbage collection. It's time for, is this canary? No, let's go for canary. I was just checking it wasn't already canary. It doesn't automatically do that. So if I click the reload button, or okay, click the reload button there. That's how we do it now. No longer automatically does it whenever you refresh, just when you happen to have the tab open. Very similar picture. Absolutely nothing happens. Loading the profile, and then this comes in. What is going on? Okay, let's try this again. So, refresh, record. Come on. Yeah, initializing the profiler doesn't finish until after it's done whatever it's doing. Something really is taking up all the time, but Chrome will not let me discover it. So basically, I don't know. I guess there is a drop here. I don't know if the decoding is faster or not, because who knows? It doesn't. My code for doing the decoding is not being captured here. here's what I can do. Where do we start? Where's our while loop? Over here. I'll start recording now. Did it again. So it's waiting for that process to finish, whatever it is that it's doing, before it starts the profiler. It's pretty annoying. Yeah. I think we captured it. 4.28 seconds. That is ridiculous. Well, on that bombshell, I think I've run out of time. So here's what we're going to do. I'm going to back out this change. Okay, what I'm going to do is I'm going to save. I'm going to do a commit. Here is the GIF decoder after I messed it up. And then I'm going to just Control-Z. Control-Z all of that stuff that I just did with pulling that out, that abstraction. So that when I commit this finally, at least the code basically works. I thought that would make decoding much, much faster, and it has not. And who knows? Who knows why? It doesn't seem like it's a huge amount of data. Oh, okay. Yeah, I've gone too far. Here's our new draw loop. Visibility change. Okay, here we go. Sublog blocks really were never used. Let's just check that it goes back to working correctly. Oh no, not like that, it doesn't. There we go. Yeah, very disappointing. I think the general theory of what I was saying, that we shouldn't be loading everything into a buffer and then doing some other process which turns it into another buffer. If we can just do it stream-like, you know, we read one bit, we read 7 bits, we do what we need to do on those 7 bits, and then we throw them away so that we're not storing everything in memory, we're not copying things all over the place. That seems to me like it would make things a lot faster. But I suspect that really, if I'd profiled this, and I should have profiled it because tools are how we work this stuff out. No, we can't profile this bit. We do have to profile the startup. I suspect that what takes the time is really same problem again. We can't actually see. I suspect that what takes the time is building the dictionary with those array concats. It's my suspicion. The profiling isn't working, so who knows? Anyway, that is all I have time for. What a disappointing ending. Hopefully you learned something or were amused by my complete failure to get this done. I am thinking about what to do next. I'm probably going to do something a little less complicated, I'll be honest. So working on a spec like this is great in terms of when you've got it right, but there's no creativity or less creativity here because you're not building something from scratch. You don't have to make so many decisions. So I think next time I might do something different. We might build an app that does something. I don't know. We'll throw in some interest. Does anybody have any questions? I'll give it 30 seconds for the stream to catch up. In the event that there are no questions. I will do a stream next week. I will have a think about what we're going to do. If you want to make a suggestion, my Twitter handle is @wibblymat. Let's stick that on the screen so everyone can see it. @wibblymat. Excuse me. That is not as good as I thought it was going to be. So yeah, feel free to send me suggestions on Twitter about what I should build next. It's probably going to be a web app, PWA of some kind. I hope you enjoyed this, even though it had a disappointing ending. And I'll see you next time. Cheers.